So the next topic we are going to cover is number bases. So what are number bases? A number base is a system to represent numbers using digits. Some of the more common bases are binary, decimal, which is our number system, and hexadecimal. The base of the number is specified with the subscript. In our base we don't use a subscript because it's implied that it's in decimal. Oh, and by the way, there's going to be math in this. Okay, so digits of bases. The digits of a number base are from 0 all the way to that base minus 1. So, and after decimal, which is base 10, letters start getting incorporated as digits. So for example, binary is 1s and 0s. Decimal is from 0 all the way to 9. So 0 all the way to 10 minus 1. And then hexadecimal, since it's past 10, you have to start using letters, and it's 6 more digits than decimal, so you need A, B, C, D, E, and F for the 16 digits along with 0 through 9. So converting to base 10. Converting to base 10 is really simple once you understand how number systems really work. So you learned this back in elementary school. It's called expanded form. Here's a quick example. So 1337 is 1 times 10 to the third, or 1000, plus 3 times 10 to the second, or 100, plus 3 times 10, plus 7 times 1. 10 to the 0 is 1, but it's important to write 1 as 10 to the 0 because it helps you understand how this really works. Numbers in decimal are represented based off of powers of 10, starting from 10 to the 0 in expanded form. So in the previous example, it starts from 10 to the 0 and it goes from 10 to 10 to the 1, then 10 to the 2, then 10 to the 3. And in different bases, such as binary, numbers are represented based off of powers of 10 or 2, or in hexadecimal based off of powers of 16. So all these 10s would be 2s if it was in binary. Converting binary to decimal. So this is an example. 110.100.100 base 2. The subscript tells you it's binary. So when you write it out based off of the powers of 2, 0 if it is this power of 2, so 0 times 2 to the 0, and you do all the calculations, you get 420. Notice how the digits of the 0 in the 1's place match to the 1's place in base 2. So 2 to the 0, so the 0s is the coefficient, I guess. And yeah, they map, so that's how you convert. And so you start from 2 to the 0 and then you keep working up. You could probably see the pattern. Also a quick note, you know you are doing this process correctly if you cover up the powers of the base. So you would cover up the 2's in the number, or you would get the original number. So if you cover up the 2's, you go going backwards, 0, 0, 1, 0, 0, 1, 0, 1, 1. That matches up with the example. And also the number of terms is equal to the number of digits. So terms, exponents are 0 to 8, that means there's 9, and I count 9 digits, so that is correct. And the number by which you are multiplying the digits is the same as the base. So you're multiplying by powers of 2, and it's binary, which is 2. So, yeah. Now it's your turn. You're going to convert this number to decimal. It's in binary. Just try it in the blank space provided if you want. So using this the method from the previous slide, you get 69. Just to make sure, starts to 0 to the 0 goes up to 2 to the 6. That means there's 7 digits, or there's supposed to be. And yes, there are 7 digits, and the base looks correct, and hopefully the math is right. Okay, next slide. So now we're going to try converting from hexadecimal to decimal. And again, since this is greater than 10, 16 is greater than 10, so you're going to have to start using letters now to represent digits. And sort of the formula is the place value of the letter in the alphabet, and then you add 9. So A is the first letter of the alphabet, add 9, so that's 10. So instead of 10 like 10, it would be 10 as a digit. It's kind of weird, but yeah. Okay, so the example A1. Okay, so base 16. So A is value of A is 10 because it's 1 plus 9. So 10 times 16, then plus 1 times 16 to the 0, so 161. So now you try the next example, C4 base hexadecimal, and convert that to decimal using the same method in the previous example. Okay, so the answer you should have gotten is 196. If you do the math, C is the third letter of the alphabet. 9 plus 3 is 12 times 16. That is 192. And then 4 times 16 is 0. That's 4. So 192 plus 4, that is 196. So that's all we're going to go over in binary. And sorry, that's all we're gonna go over on bases, number bases. There's different other things you could do with number bases, but it's gonna take too long. So here's a bonus problem: convert G in base 16 to decimal. Okay, so this problem is actually a trick question. So let's calculate the value for G. It would be 7 because it's a letter or a 7th letter of the alphabet, then plus 6. So, no, sorry, 7 plus 9. So 16. And 16 is more than 15. And remember that hexadecimal goes from 0 all the way to the base minus 1. So 16 minus 1 is 15. And also digits greater than 10 are letters now, or sorry, digits greater than 9 are letters now, so it would be 1 through 9, and then A, B, C, D, E, F, so G would not be included. So the next topic we're going to talk about is TCP. So how do computers send and receive information? Computers send information following a procedure called a User Datagram Protocol, abbreviated as UDP, and Transmission Control Protocol, abbreviated as TCP. Also, you only need to know TCP for the AP exam, but UDP is relevant to this topic of discussion also. So, what are UDP and TCP? If you're following along, one of the fill-in-the-blank questions, UDP and TCP function similarly. In UDP and TCP, data is broken down into chunks called packets. The computer transmits the packets through a network of routers, which are specialized devices that direct the traffic of packets. When packets are sent through networks of routers, they are sent in a fashion that is the quickest but not necessarily the shortest in distance. This process is comparable to that of driving a car. It is more efficient to take roads that are less congested to save time. Those road paths might not be the shortest route. So what is the difference between UDP and TCP? So first, TCP, this is a definition on the handout. TCP is a reliable method of transmission that guarantees messages reach their destination. If packets somehow don't make it to the final destination, the packets are resent. And unlike TCP, UDP is an unreliable method of transmission, meaning that packets aren't resent if the computer doesn't receive them. So does this mean TCP is better than UDP in everything? No. They both have their benefits, so we're going to go into that. The benefits of TCP. TCP calls for checks to ensure all packets are received, making it a reliable form of data transmission. If all packets are received, messages are sent between servers to acknowledge that the process was successful. As a result, no corruption occurs throughout the process. TCP is more commonly used than UDP in instances such as browsing websites or giving presentations about TCP on a website that stores your PowerPoint in the cloud. So, benefits of UDP. The main difference between UDP and TCP, besides the name, is that UDP does not resend packets that get lost in the traffic in the router network. Because UDP doesn't perform packet checks, it is consequently a quicker means of transmitting data that doesn't need to be completely recreated at the moment. And UDP is used in instances such as online games and live streams where internet is constantly being updated. So, quick recap, data is transmitted by breaking the data into packets, and these packets are sent through a network of routers. The path they take to get from initial destination to the final destination will not necessarily follow the quickest path, not necessarily follow the shortest path, but it will follow the quickest path possible. And the difference between TCP and UDP is that TCP is reliable and it checks for all the packets received, while UDP does not check for all the packets received, making it unreliable. So there was a snap simulation for TCP. It wasn't really important. The main thing that I took away from this is that it demonstrated that the TCP processing speed is variable because TCP ensures all packets are received by re-requesting packets to construct the whole entity, which can sometimes take a while when the internet traffic and random errors are taken into consideration. So basically this program it modeled a delay. That was really it. There was just a delay. That's what I took out of this. And that is it for TCP and UDP.